We are continuing on with investigation 2.3. And what we're trying to do is we are actually going through each one to figure out which explanation or which scenario goes with which graph. So we've already determined that A goes with graph number 2. So graph 2 is A. All right. So now what we're on is B. And B, we said, was time and speed. All right, so when a skateboard rider goes down one side of a half pipe ramp and up the other side, her speed changes as time passes. All right, so if we look at graph 1, as time is passing, the speed is going up, and then it levels off, and then it goes up again. I don't see that happening when a skateboard rider is going up and down a half pipe. And they show you a picture of a half pipe. It's basically this. So therefore, oh man, I get to see if I can draw. All right, so we got the little guy on the skateboard. Okay, so as he goes down, his speed will increase, and then eventually his speed will slow down as he gets up to the other side, and then he swings back the other way. All right, I love my drawing. All right, so graph 1, no. Graph 2, as the time goes by, his speed is decreasing. That's not going to work. Graph 3, as time goes by, his speed is increasing, and then he slows down, and then he increases. So that could possibly work. So we will say graph 3 could be B. Okay, graph 4, as time increases, speed is increasing. No. Graph 5, as time increases, speed is decreasing. No. Graph 6, as time is increasing, speed is increasing, and then it decreases. So it could also be graph 6. So we have two possible scenarios for B. It could be graph 3 or it could be graph 6. It really depends upon, are you thinking about continuously going back and forth, or are you just looking at just one particular down, up, and then down, well, down and up, and then he stops. So we have two scenarios for B. All right, so now we're on to C. Oh. So remember, when you do these, you have to have an explanation as to why you picked what you picked. So you have to give a little scenario about it. I guess I should erase it. No, I'm going to leave the drawing because I like the drawing. All right, C. The water level changes over time. So we already said this is time and water level. All right. All right, as someone fills a tub, takes a bath, and empties the tub. All right, so we got three things going on. Fill, bath, empty. Okay. So as time increases, as I fill it, the water level is going up. That will work. So that means this one will work. This one won't work. This one could work. This one could work. This one won't. Yeah, that's a much better way to do this. Okay. Then I take the bath. So in other words, I fill it up. Potentially the water could be sitting there for a while, and then I get in it, and the water level goes up. I'm taking my bath. I get out, and then I empty it. So this could be C if I break down each part of it. All right, graph 3. So I fill the tub up. I take my bath. That's not going to work. So that one's not going to work. Then we said this one, 4 won't work at all. Okay, because that's just filling it up and it just keeps filling. And which one? 6. 6, fill the tub up so the water level goes up. Take my bath. 6 maybe, but I'm really feeling C. All right, so C seems to work the best for that one. Okay, but again, it really does depend upon the story that you're going to use. Oh, why did I just erase that? All right, so this is graph C. All right. D. The waiting time for a popular ride at an amusement park is related to the number of people in the park. And we said number of people determines the wait time. All right. So what we're looking for is, as the number of people increases, my wait time increases. This could work. As the number of people increases, my wait time decreases. Nope. Increases. Then at a certain point it goes down. I don't see that happening. Goes up and down. Definitely don't see that happening. Goes down. Not a chance. Goes up. So increases. Levels off. Goes up again for some reason. Levels off and then goes down. Don't see that happening either. So we're left with just one option. Graph 4. Okay, so as my wait time, as the number of people in the park increases, my wait time increases accordingly. All right, so that's D. Are you guys trying to figure out if I'm going to do all of them or not? We have E, F, and G. All right, I think I'll do E. Besides, I'm running out of colors anyway. All right, so I'll do orange. E. The number of hours of daylight changes over time as the season changes. Oops. All right. And we said that was time daylight. All right, so as the season changes, the daylight changes. Okay, I don't see graph 1 working. This is decreasing daylight as the seasons go. No, it's going to be pitch black at some point. As it changes, it goes up, it comes down, it goes up. That's possible, so maybe. Daylight increases constantly. Nope. Daylight decreases, then increases. Possible. Daylight increases, then decreases. Possible. All right. So this one is going to depend upon how you're looking at the scenario. Are you looking at it from one season to the next? So basically, are you saying, okay, as I go from winter into summer? You could say that one. You could say graph 5. Okay, so graph 5 could be. Graph 6, as I go from summer, or from spring to summer to fall and then to winter. Graph 6 could work. Graph 3 could be over the years. Okay, so this could be over several years. So it all depends upon how you are going to explain the scenario. So I'm going to basically say that E could be any one of these 3, depending upon the story that you want to tell about the seasons. Are you talking about just from summer to winter, or are you talking about over years? Are you talking about from winter to summer? So it does make a difference as to which graph you pick. All right, so that goes all the way up to E. I'm going to leave F and G up to you. That's only 2, so figure those 2 out. And don't make fun of my drawing.